Hi guys, welcome to Module 1, Lesson 2. I am recording this and hoping that this will record as a lesson for you to watch. So I'm sharing my screen right now and I will be recording this one and sticking it here. You'll notice on here that I also have an applet that I'll review, and so I will put up also a video of me showing that applet with the data that we do for an example. The Explore here is almost a review from yesterday, but I'm going to tie it into what we're doing today as well. So looking at the Explore on social media, if you read the article, it's pretty interesting stuff. But with the social media apps here, you'll notice that this is categorical data. So we have Facebook, WhatsApp. These are the different apps worldwide that are in use that are most popular right now. Now, Facebook being number one, but that right there shows you a bar graph because these are categories. Today, we're going to be looking at histograms, and histograms are quantitative data. So they look like bar graphs, but they will not have space in between them. That's the main thing. And also, it will be quantitative. Instead of having categories here, it will be numbers instead. So that's going to be the main difference. So I will show the key for notes. When you guys are ever struggling, I do have a key for notes here that you can go to and get some other examples. We're going to look at a different example than this, but I do want to review this before I break into the example that I have here. Histograms are going to be our third and actually most common way to represent quantitative data. And the reason is typically our data sets will be on the larger side, like even when I'm collecting data from you guys and I have 38 data points. That's a lot. I don't want to do a stem plot with 38 different values. So we're going to use a histogram instead. Histograms work in this way. We create what are called class frequency tables. So class means whichever values I'm going to do, I create like a width, like a class width where it has to be a common width. And frequency, it means I'm just going to literally count how many fall within that width. So when I look at this here, I'm going to zoom in a little bit so you guys can see this table for the age of presidents at inauguration. You'll notice that the youngest president ever inaugurated was actually Teddy Roosevelt. He was 42 at inauguration. That's our youngest president. And the oldest, which didn't make it on here, this data set was from a little bit earlier, but is actually Donald Trump. He was 70 when he was inaugurated, the age at his inauguration. So youngest and oldest and everything in between. So when I go to set up the intervals for this one, if I were to do it in chunks of 10, I would have from essentially 40, 50, 60, 70. That would only give me 4 bars, and that's a little bit light. You always kind of want to have more than 4 bars, like 5, 6, 7 bars. So what I did instead, and you'll see here, I broke it down in groups of 5, 40, 41, 42, 43, 44. So that's a class width of 5. 45, 46, 47, 48, 49. So those are all 5. These all have to be the same number, the same class width. They have to represent the same numbers. So there are 5 numbers from age 40 to 44. The other thing you'll notice is that in the actual graph, when I look here, this 40 is this part of the graph. Then we go to 45. You're always using this front number in order to create your actual histogram. So 70 at the end of this one, you'll see 70 to 75. Okay, so that is going to be how we design a histogram, and I'm going to go over one with you in just a second. But just a quick reminder from yesterday, after we do that, we'll look at center, unusual feature, shape, and spread. I actually do want to come up into this document to show you kind of how we would talk about that. The center of this is definitely going to be somewhere in here, and right now I'm just going to generalize and say it's between like 50 and 60 years old. The reason I know that is because this is roughly symmetric. That's the shape of this. There are definitely no unusual features, so that's my U. There are no unusual features. Nothing like stands out to me, a certain one that's maybe a lot older or a lot younger here. It's all about in that same range. And our spread is from, and I have to actually look at the data. I can't tell in the graph. The spread is from 42 to 70. So that's how I would cuss about this data, and we'll continue to do that a little bit today. The one thing that we didn't cover yesterday that we're going to cover today are 2 extra shapes that we have here. Symmetric looks like a bell. That's this right here. And I'll talk about what these mean when we get into mean and median. But a symmetric looks like that bell. This one is skewed to the left because if you think about it, there's a bump and then there's this tail to the left. There's a tail to the left. So that one is skewed to the left. And this one would mean most of your data is here, but then you have this like tail off to the right. So you literally have to think of it as wherever that tail is, that's where it's pulling you. It's either skewed right or skewed left. I put here, like on this one, think you would actually ski right on this one, right? Like skiing down a slope, this one you would be skiing to the right. This one you would be skiing to the left. So that's the idea of that. Okay, I'm gonna go ahead and pause the video now and see where we're at on time, and then I will pop in to do one more example.